Right, so last time we were trying to prove this theorem, which is about conservative fields and path independence. Okay, so this was the statement. If you have an open connected domain and a smooth vector field, then these three conditions are equivalent. Namely, f is conservative. First one. Second one is around any closed loop, the line integral of f is 0. And the third one is the integral is path independent. Namely, if you have 2 points, then the integral along f along any curve joining these 2 points has the same value no matter what the curve is. The only important thing is that it has endpoints P0 and P1. Starts at P0 and ends at P1. And we proved this. At the last part, last time I was a little bit confused. I corrected it. Okay, so yeah, this was the part. Okay. Oh. Here we are using the fundamental theorem of calculus. You see, you have a function of two variables, but actually it's the only variable here is t. You are integrating with respect to t. And here this end is fixed, this end depends on h, and you are taking derivative with respect to h. So this is exactly the statement of fundamental theorem of calculus. The limit of this as h goes to 0 is just the interior function evaluated at this point, and that is so at the point x minus x0, x minus x1. So here instead of t you write x minus x1, and then you get this. Okay, so what we do is exactly the following. So the derivative ddt of what, or dd x, okay, a to x f of t dt is, we know that fundamental term of calculus tells us that this is just f of x, but this expression is nothing but, can be written like this: limit as h goes to 0, a plus from a to x plus h f of t dt minus a to x divided by h, and the numerator is just so this is integral from a to x plus h. This is integral from so here I have f of t dt a to x, so the numerator is just integral from x to x plus h f of t dt divided by h. So it is exactly what we have here. Okay. Okay, now let's see some examples where we use this result. Well, not really actually, but some examples of line integrals, let me say. Okay, first one is this. For what values of the constants A and B is the vector field F, which is given as A times X times sine pi times Y I plus X squared cosine pi Y plus B times Y times e to the power minus t j plus Y squared e to the power t k conservative. Uh, for this choice of A and B, evaluate the integral. So C f dot dr, where C is, it has two parts. First one is the curve r equals cosine t I plus sine 2t j plus sine squared t k, where t is ranging between 0 and 2 pi, and the second curve b, the curve of intersection of the paraboloid z equals x squared plus y squared and the plane z equals 3x minus 2y from 0, 0, 0 to 1, 1 over 2, 2. Okay. Now, first of all, let me rewrite f again. F is a times x times sine pi y I plus x squared cosine pi y plus, plus b times, so here y e to the power minus t j plus y squared e to the power minus tk. Now, for this to be conservative, we have a necessary condition. The necessary condition, okay, a necessary condition for f to be conservative, what was that? Is the following. Eğer f'in komponentleri f1, f2, f3 ise neydi bu koşullar? Okey. F1'in hatırlarsanız şurada ben onu yapmıştık daha önceden. İki tane olunca işte x ve y'ye göre türevleri geliyordu ama değil mi? Yani şöyle diyeyim. Aslında isterseniz onu da hatırlatmış olayım. So if it is conservative, then it is the gradient of some function. So it is f1 is phi sub x, phi sub y, and phi sub z. And then you have what? Well, y derivative of f1 is xy or yx, but this is xy, therefore this is x derivative of f2. Similarly, z derivative of this is just zx, and this is xz, and this is just f3x. And the third one is that x derivative of this, so this is just no, sorry, f2'nun y'ye göre türevi yok. Şimdi f1, f2 z'ye göre türevi. Bu nedir? Phi zy. So this is phi yz. Bu da nedir? Del f3 del y. Hı hı. f3 buna eşit. Bunun y'ye göre türevi. Okay. So I have this three equalities. F1 is so F1 is, in our case, let me write those down. F1 is ax sine pi y. F2 is x squared. Okay, x squared cosine pi y. Yani şurada da tabii. Neyse şuna gerek yok. Pi y artı by e to the power t. And f3 is y squared e to the power minus t. So let's see. F1'ın y'ye göre türevini alıyorum. Ne olacak bu? A pi x cosine pi y. This should be same as derivative of f2 with respect to x. Derivative of f2 with respect to x is just 2x değil mi? F1'in y'ye göre türevi, F2'nin x'e göre türevi. F2'nin x'e göre türevi de nedir? 2x kosinüs pi y. Bunun bu t değil, bunlar z. Özür dilerim. Evet, t yok. Buralarda da t mi yazdım? Şunları z yapayım. Okey. Z'ye göre türevini pardon, x'e göre türevini alıyoruz. Bunun x'e göre türevinde tabii ki burası 0 verecek. Sadece bu var. Buradan ne çıkar? So this is del f2 del x. So from this, if you compare this two, you get a times pi is equal to 2, right? Therefore, a is just 2 over pi. Okay. And what about this condition? Del f1 del z. derivative of this with respect to z is just 0, and this should be f derivative of f3 with respect to x. Well, that is also 0, del f3 with respect to x. So this is automatically satisfied. And the third condition is that, okay, del f2 del x del z, del f2 del z, f2'nun z'ye göre türevi nedir? So this is minus b y e to the power minus z, and this should be y derivative of this. Well, y derivative of this 2y e to the power minus z. So this is this gadget, and from this we get b is equal to, or minus b is equal to 2. Therefore, b is minus 2. So hence f should be okay. A is just neydi? 2 over pi miydi? 2 over pi, and b is equal to minus 2. O zaman f de nedir? F'i yazarsak 2 over pi x sine pi y I plus x squared cosine pi y minus b, which is minus 2 z j plus y squared e to the power minus z times k. So f is this. Now this is a necessary condition for f to be conservative, but it's not a sufficient condition in general. To show that f is really conservative, one has to find an potential function. So look for potential function y x y z. Ne olacaktı? Bunun x'e göre türevi f1, yani 2 over pi x sine pi y. Okay. From this we see what? Phi should be what? X derivative is this. Therefore, phi should be what? X squared over pi. I am taking the integral with respect to x. Sine pi y plus a function of y and z. What is this function? Well, this function to be determined. All right. We don't know what this is. How can we determine that? Well, we will determine that using the other equations. Phi sub y should be f2. Well, this is phi. Its derivative with respect to y is just what? When you take derivative with respect to y, you get x squared cosine pi y plus 8 sub y. It should be f2. What is f2? f2 is this. So x squared cosine pi y minus 2y e to the power minus z. And from this, we see what? We see that, so these are the same. 8 sub y should be minus 2y e to the power minus z. So h is a function of two variables, and its y derivative is this. Therefore, h should be what? H yz is the antiderivative of this with respect to y. So it is minus y squared e to the power z plus some function of z. Right? It's a function of two variables. When you integrate this with respect to y, you should get a constant term, and the constant term in general may include z variable in it. So from this we see that phi is equal to what? X squared, and here of course we have to find what this function is, right? Like this one. So phi is just x squared over pi sine pi y plus h. H is y squared e to the power minus z plus gz. And how do you find this g? I have to write down the third equation, that derivative with respect to z is f3. So take derivative with respect to z, you get y squared e to the power minus z plus g prime z, and this should be f3. What is f3? F3 is this, y squared times e to the power z. Sorry, artı eksi. Okay. Şimdi ne dedik? F3 olacak. F3'de neydi? F3 y squared e to the power minus z. Ama burada bir terslik var. Bir terslik yaptık. Nerede? Ha, şurada tabii ki F2 bir dakika. Tamam. B, Y, E üzeri Z. Onun yerine eksi 2 koyduk. Tamam. Burada eksi 2 var. Y'ye göre türevi bu. Bunun Z'ye göre türevini alıyorum. Yok, bir saniye. Z'ye göre türevini aldığımda burası artı olacak. Değil mi? When you take derivative with respect to z, you get plus. Okay. And from this we see that g prime z is equal to 0. Therefore, g is really constant. Constant. So, phi can be taken to be as what? Phi, which is a function of x, y, z, and that is just x squared over, okay, so pi squared over x squared over pi sine pi y minus y squared e to the power minus z, and gz is just a constant. I can take any constant, but why not take just 0, okay? What I am looking for is just one antiderivative. So I can just choose this constant, anything I want. I can choose c, but then I can just let it to be 0. So our f is just gradient of phi, and hence, and thus f is conservative. Peki şimdi A şıkkına bakalım. A şıkkı neydi? Bir tane curve vardı, değil mi? Neydi curve? Pardon, fazla gittik. şu curve'dü. Cosine t, sin 2t, etc. So let me write from the, so RT is this cosine tj plus sine 2t, no, this is cosine ti, this is j, and sine square tk, t from 0 to 2 pi. Well, you see, this curve, when you plug 0, you get I and then 0. And this is the same thing as if you plug 2 pi. So that this curve is closed. Okay. So this curve starts at a point and ends at the same point. Okay. So R0 and R pi. Well, the line integral along a closed curve is 0, right, by the theorem, since f is conservative. Değil mi? We proved that if a vector field is closed, conservative, then around any closed curve, the line integral is 0. Neden? Yani nedeni de bariz tabii ki bunun şu yüzden. F dot dr dediğimiz şey gradient of f dot dr. Bu da sonuçta şeye geliyor. Phi'ın işte R0'daki pardon, 0 değil bu şey 2 pi, R 2 pi'daki değeri minus R0'daki değeri, but these 2 points are the same. Okay, this point and this point are the same, so they are the same, therefore this is 0. Okay, if this is point P, then this is also P, therefore it is 0. Okay, for part B, it was this curve, the intersection of this paraboloid, x squared plus 4y squared, değil mi? Öyleydi. Bunu yanlış yazmışım. X squared plus 4y squared olacak. Özür dilerim. X squared plus 4y squared. And the intersection of this with the plane 3x minus 2y from the point 0, 0, 0 to 1 over 2, 2. Okay, let's see what kind of object is this. So this is a paraboloid, something like this. Okay, and you cut this via some plane. Okay, what you should get some ellipse. Okay, let's see what is that ellipse. So you equate z's, so x squared plus 4y squared is 3x minus 2y. Okay, so this is what? This is just x squared minus 3x plus 4y squared minus y over 2 equals 0, right? Pardon, şurası artı olacak. Bunu şöyle yazabilirim. This is x minus 3 over 2 squared and this is y plus 1 over 4 squared, değil mi? Karesini alırsanız y kare artı y bölü 2 artı bir şey gelecek. Şimdi burada ekstra hangi terim var? 9 bölü 4 var. O zaman bunu eklemem lazım. Çünkü bunu karesini açtığımda 9 bölü 4 geliyor. Burada da bunu açtığımda 1 bölü 16 gelecek. 4 ile çarptınız. 1 bölü 4. O zaman buraya da 1 bölü 4 ekleyeceğim. Yani ne elde ettik? X eksi 3 bölü 2'nin karesi artı 4 tane y artı 1 bölü 4'ün karesi eşittir 10 bölü 4. Okay, so in the xy plane, this is an ellipse with center, so 3 halves and minus 1 over. So something like this. And this is an ellipse. Y komponentu 4 ile çarpılıyor. O yüzden herhalde şöyle bir şey yani. So this is an ellipse, something like this. Okay. Okay. And okay. The points were 0, 0, 0. So this ellipse goes through this point. 0, 0, 0'dan geçiyor, değil mi? 0, 0 koyarsak 9 bölü 4. Evet. Şu noktadan geçiyormuş yani. Şöyle bir şey o zaman. Alright. Now our vector field is conservative, therefore integral of f dot dr, which is just gradient of phi dot dr. I have to parameterize this curve to compute this. However, since it is conservative, this is just, if this curve is C, okay, C, this is the point 0, 0, 0, and this is the point 1, 1 over 2 and 2. Then this integral is just phi of 1, 1 over 2, 2, and phi 0, 0, 0. Since it is conservative, the only thing it matters are the endpoints. So you just need to compute this at the endpoints. Phi was this function. Bir daha yazayım şunu. Neydi? Bunu hesapladık. Evet. X squared over pi sine pi y minus y squared e to the power minus z. So when you plug this point, you get what? Sine, so x squared over 2, 1 over x squared over pi, sine pi over 2, yes, minus 1 over 4 e to the power minus 4, minus, when you plug 0 for x, y, z, you just get 0. So the result is sine pi over 2 is just 1. So 1 over pi minus e to the power minus 4 divided by 4. 4 nereden geldi? 2 olacak burası. Değil mi? Z2. Y 1 bölü 2. Tamam. Oradan 4 geliyor ama burası 2. Tamam. Şu şeyi yaptık değil mi? Yani bu konservatifse sadece endpointlerde şey oluyor. İsterseniz onu açıklayayım tekrar. Yani eğer vektör field'ımız konservatifse bir tane C eğrisi olsun. R, T, T işte A'dan B'ye kadar. Yani şöyle bir eğrimiz var. C eğrisi R of A, R of B. Bu eğri diyelim ki has components xt, yt, zt. Then dr is just x prime, y prime, z prime, dt. So f dot dr, f dot dr over this, we just parameterize this from a to b. F is just gradient of this dot dr. So this is just a to b. What is this? Well, this is x derivative, y derivative, z derivative, and dot product with x prime, y prime, z prime dt. But this is a to b. So phi sub x times x prime plus phi sub y, y prime, phi sub z, z prime dt. But then the observation was this. I think I did this while we were trying to prove the theorem. What is this? This is nothing but d over dt of phi of xt, yt, zt. Right? Because when you take derivative of this, what you do? You take derivative of this with respect to the first variable, which is x, times derivative of x with respect to t, plus derivative of phi with respect to the second variable, which is this, times derivative of y with respect to t, plus derivative of phi with respect to the third variable, which is z, times derivative of z with respect to t. So this whole expression is just t derivative of this. But then I am taking derivative and then integral of this. Well, this is just by the fundamental theorem of calculus. This is phi xt, yt, zt computed at t equals a and t equals b. When you plug b, you get phi of r b minus, when you plug a, you get phi of r a. So this integral is just the difference of the values of the function, potential function at the endpoints. Yani şey gibi düşünebilirsiniz. Mesela bu gravitational vector field ise bu potential enerji fonksiyonu. Yaptığınız iş nedir? Yüksekliğin, değil mi? Yani potansiyel enerjinin bu noktalardaki değerlerinin farkına eşittir. Onu söylüyor. So for a conservative field, line integral is actually just can be computed as the difference of the potential function at the end points of the curve. Okay, it is not indeed a line integral. You just need to compute the function at the end points of the curve. All right, let's do one more example. Sorusu olan var mı? anlaşılmayan bir şey? Another example. Evaluate I, which is closed integral of this e to the power, sorry, this is x sine y plus 3y dx plus e to the power x cosine y plus 2x minus 2y dy counterclockwise around the ellipse 4x squared plus y squared is equal to 4. So this time f is this e to the power x sine y plus 3y. This is the x coordinate. So f1 y coordinate is just e to the power x cosine y plus 2x minus 2y. So f1 and f2. Let's see if it is let's see if f is conservative. Yani doğrudan hesap yapmaya kalkarsanız bunu parametrize edeceksiniz. Ama parametrization'da işte yani 4x squared plus y squared equals 4. Bunun parametrization nasıl olur? Neyse yapacağım onu da ya da yapalım şöyle 4x squared plus y squared is 4. How can you parameterize this? Well, you write this as if it's a circle equation. So this is x squared plus, right, y over 2 squared equals 1. So squares add up to 1. Therefore, you should let x to be just cosine t and y over 2 to be sine t. So that x squared plus, sorry, y cosine t squared plus sine t squared is equal to 1. So x is just, xt is just cosine t and yt is 2 times sine t. Now, if you want to compute the integral directly, you have to take x and y and plug into this equation, and then you have to compute this. But, you know, it looks a bit complicated, right? So let's see first if it is conservative. If it is conservative, then the integral would be just 0. So f1, f2, which is e to the power x sine y plus 3y, and then e to the power x cosine y plus 2x minus 2y. And if it is conservative, then this should be phi sub x and phi sub y. There are only two variables, x and y, though that's why I don't, you know, have to deal with z coordinate. So if it is conservative, then phi sub x should be e to the power x sine y plus 3y. Well, then what would be phi? Integral of this with respect to x. Well, that is just e to the power x sine y plus 3xy plus a function of y. What is this h? Well, we have to determine it using the second coordinate. Phi sub y should be e to the power x cosine y plus 2x minus 2y. So phi sub y is what? When you take derivative of this, you get derivative with respect to y, e to the power x cosine y plus 3x plus h prime y. So this should be e to the power x cosine y plus 2x minus 2y. Well, this is not conservative, right? This is not conservative, and the reason is that here I can choose h prime as this one. There's no problem with that, but this thing here, okay, this is 3x, this is 2x. So that's why this is not conservative. However, I can do this. If I replace by this 3x with 2x, then I would be fine. So, uh, hence f is not conservative. However, we see that this gadget, so let's say g, okay, which is e to the power x sine y plus 2y e to the power x cosine y plus 2x minus 2y is conservative. So I just replace this by 3y by 2y. And what is this? This is just, so phi is this function, namely yok şuydu, yani şu seçersem where g is gradient of phi and phi is this. E üzeri x sinüs y artı 2xy eksi h prime'da 2y olacak. H prime 2y ise h nedir? Yeah, h prime is minus 2y, so I can just take h to be minus y squared. Değil mi? Gerçekten de bunun x'e göre türevini alırsanız derivative of this with respect to x is this, right? And derivative of this with respect to y. Bakalım x'e göre türevi nedir? Bu var. İşte 2y. Y'ye göre türevi bu terim var. Bu terim var. Bir de bu var. O halde f konservatif değil. Moreover f is what? F is just g plus f ile g'nin farkı nedir? Sadece bir tane y var. This. Okay. So gradient of f dot dr along this closed loop is equal to what? This is integral over g plus this gadget dot dr, but you see this integral can be written like this. This gadget plus integral of y comma 0 dot dr. Here this is conservative, and since it is conservative and this is a closed loop, this is 0. Therefore I have only y comma 0 dot dr because g is conservative and c is a closed loop. Okay, closed loop. So now this integral f dot dr is just y comma 0 dr, and let's compute this in the second hour. Okay.